Hello everybody. In this video we are going to embark on our journey of equilibrium existence in infinite economies. We're not going to be going and working through any proofs of equilibrium in an infinite economy or proving any theorems in this video. Rather, what I want to show is why our old tools that we use to go and prove equilibrium existence in a finite environments do not carry over to cases where we are going and talking about infinity. Infinity makes things very, very, very weird. And with that in mind, let's go. So a natural question to go and ask is that if it's possible to prove equilibrium existence in an economy with n many goods, and in turn an economy with n plus 1 many goods, what's stopping us from a proof by induction and proving equilibrium existence in an infinite number of markets? The answer is the excess demand function here. So we're going to go and look at this thing, and this is really the source of this problem here. But still, we have some questions. What's stopping us from defining a infinite excess demand function that we go and we have here, and saying by Walras's law, right, where we have some p being this infinite price vector, multiplying this infinite excess demand function, that's going to be equal to 0. And this is not correct. And we're going to see why this is not correct, or one reason why this is not correct. So recall, in exchange economies with n many goods, a Walrasian equilibrium is one where we have our sum total of demands across all markets I, from where I goes from 1 to n, is going to be less than or equal to the sum total of our endowments in all n markets. Now consider the case where n tends to infinity. In this case, we're just going to go and replace that n, and we're going to put a infinity symbol here. Now we need to think about what we're looking at. There's no guarantee that our left-hand side, right, which is our sum total of our Marshallian demands across these infinity of markets, converges to a finite value. And our right-hand side is just a series of scalars, so it diverges out to infinity. Thus, it's possible to have infinity is less than or equal to infinity, right? And the problem with the above is that we can't derive a infinite excess demand function, right, which would be very nice, but we can't go and do arithmetic with infinity, right? We can't subtract infinity from infinity, right? That's undefined there, right? It's, you can't really say anything about that. So this is why you can't go and really use our previous tools of, Walras fixed point theorem, and in turn going and using Walras's law, which depends on our excess demand function here, because it's undefined in infinity, or it's possible for it to be undefined. Certainly you can go and put some other requirements on your demand functions here for there to go and be an equilibrium, or for this to go and work, but in general this does not go and work. So what do we do now? Having demonstrated that we can't employ Walras's law because our excess demand function is undefined, where there are an infinity of markets, we need some new tools for equilibrium existence. Though this will be for another video, we're going to need tools like the Hahn-Banach theorem and require some definitions of what equilibrium looks like over time, such as Arrow-Dubrow competitive equilibrium and Radner, otherwise referred to as sequential market competitive equilibrium. Keep in mind that we must first have a definition of what equilibrium is before we go and we prove it. In our context, it has just been a simple one where we're talking about supply is equal to demand as embodied by our excess demand function and Walras's law, because that's all really what our excess demand function is going and saying, or really Walras's law is going and saying. It's saying that we have a price that goes and clears this demand minus supply across all markets there. So this is really just the start of a much longer discussion on equilibrium existence in infinite economies. I hope this piques your interest and gives you an idea for why we can't use proof by induction for infinite economies. I hope this helps. Take care.